Hey, man. All right, guys, here we go. Oh, sorry, I had to turn off the music real quick. Here we go. Let's take care of these solving trig equations. This is your next UH quiz. So the first question, it says cosine 7x equals -1, and they want all the answers between 0 and pi over 2. So my first move is to just write the expression cosine 7x equals -1. And then to get rid of the cosine, I have to do inverse cosine because that's how this works, right? If I want to get solve for x, so I'm going to write 7x equals, and because it's inverse cosine, I'm going to write plus minus arc cosine of -1 plus 2 pi n. And then I'm going to go ahead and tell you what cosine of arc, well, this just means cosine of what angle is -1, and that happens on the unit circle at pi. So I'm going to write 7x equals plus minus pi plus 2 pi n. And then from there, I need to get x by itself, so I'm going to just divide by 7. Divide by 7, divide by 7, divide by 7. So x equals plus minus pi over 7 plus 2 pi n over 7. So yeah, we were only going to have, let's see. So one answer for sure is going to be pi over 7. And then if I add 2 pi to pi, because that's 1 pi there, the denominator is a 7, I'm going to have 3 pi over 7. And that definitely is lower than half pi. See, because if I had this denominator was a 6, that would be half, right? But the denominator is a 7, so it's one more than 6. So that means you have 3 pi over a larger number than 6, 7. So that means it's less than half. 3 pi over 7 is less than half a pi. And there it is. So pi over 7 and 3 pi over 7. All right, next one, guys, we're doing the same thing. I'm going to start by inversing both sides. So I'm going to have 11x equals plus minus arc cosine of 0 plus 2 pi n. And then cosine is 0 right at pi over 2. So I'm going to have 11x equals plus minus pi over 2 plus 2 pi n. And then I'm just going to divide by 11 because that's how you get x by itself. Divide by 11, divide by 11, divide by 11. So we have x equals plus minus pi over 22 plus 2 pi n over 11. When we do that, so one answer is pi over 22, right? So x equals pi over 22. What's another answer? Well, you got to find a common denominator here, guys. This 2 pi over 11 is the period, and that n, remember, is an integer. It just really means just how many cycles you've done. Integer. So multiply this by 2 over 2. So you're going to get 4 pi n over 22. And now you can take the -1 and add 4 pi. So if I go negative pi over 22 plus 4 pi over 22, you're going to get 3 pi over 22. And there it is. So in case you're wondering, Chop, what did you do? I went negative pi over 22. And I made n equal 1, and I got a common denominator, plus 4 pi over 22. See? And there it is. Those are my two answers between 0 and 2 pi and 2 pi over 11. If you take the positive one and you add 2 pi over 11, you're outside the domain because this is the outskirts, right? I'm looking for all my answers between 0 and 2 pi over 11. So notice that your period is 2 pi over 11. So you can't add it to the positive one, but negative pi over 22 plus 2 pi over 11 will put you inside that domain. And there it is, guys. All right. Next question. Big stepper. Okay, I'll stop. It says cotangent equals negative square root of 3. So the first thing I would do, guys, you can mess around with cotangent if you want, but I think it's always easier to mess around with tan. So I would go tan x equals, and I would just take the reciprocal of this, 1 over negative square root of 3. All right, so remember, guys, we're thinking about the unit circle. Tan is y divided by x. And the only way this will happen, you're thinking about the unit circle, is if you have a 1/2 in the numerator and a negative square root of 3 over 2 in the denominator, or a negative 1/2 in the numerator and a positive square root of 3 over 2 in the denominator. And remember, y over x. So I'm either looking for a negative square root of 3 over 2, comma 1/2, or I'm looking for a positive square root of 3 over 2, comma negative 1/2. So that's going to happen in quadrant 2 and in quadrant 4. On the unit circle, so this situation happens here. That's 5 pi over 6. And then this situation happens in quadrant 4 there. And that's 11 pi over 6. So look for that. And this individual got it correct. And let's keep going. So secant squared equals 1, guys. The reciprocal of secant is cosine. So the reciprocal of 1 is 1. So I would write cosine squared x equals 1. And then I don't want cosine squared. I want cosine, right? So square root, square root. You're going to have cosine x equals plus minus 1. And that's it. You stop and you're like, okay, well, where's cosine? Either a positive 1 or a negative 1. Well, start at negative pi over 2. So here's negative pi over 2. Because remember, if you go clockwise, it's negative, right? And I'm going to end at 3 pi over 2. So if I go one revolution like that and I stop there, that's also 3 pi over 2. So my first answer, as I'm going counterclockwise, is x equals 0. So that's my first answer. And then I keep going. I'm at pi over 2. That's not a solution. Boom, pi. That's another one. So 0 and pi. There we go. We're doing pretty good so far, guys. I hope you're doing all right. Okay, so with this one right here, guys, it requires a little bit of algebra. Do not cancel out the 8 sine x's. I know some of you maybe have that habit. Move the 8 sine x to the left, and you're going to have this. 8 sine x cosine squared x minus 8 sine x equals 0. And then I see an 8 sine x here and an 8 sine x there, so that means I can factor out an 8 sine x. So I'm going to write 8 sine x in parentheses, and I'm going to write cosine squared x minus 1, close it, equals 0. And now that I have that, I'm going to set expressions to, well, we already did this one because this one we're already pretty warmed up. So now we're just looking for true statements, right? Like what, set these expressions equal to 0 because 0 times anything is 0. So cosine squared x minus 1 equals 0. We just did this one. Previous problem. We just did this one, move the 1, right? Cosine squared x equals 1, square root, cosine x equals plus minus 1. And we said that answer was, see, it was this one, 0 pi, depending on the domain. Let's see, what's my domain? Negative 2 pi to 0. So negative 2 pi, let's see, negative pi over 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So negative 2 pi is right here. And so I'm going to go counterclockwise and get all my answers. So where's that happening? Here and here. So negative 2 pi is an answer. If it's part of the domain, yep, it is. Negative 2 pi. And then negative 3 pi over 2, negative pi. So negative pi is another answer. And then I keep going. 0 is another answer. So there it is. Those are my 3 answers. Yep, 0's in there. And then focus on the 8 sine x. And where is 8 sine x equal to 0? Divide by 8, wherever sine x is 0. Or you can also think about it as 8 times 0 is 0, right? Well, sine x happens to be 0 at these locations as well. So because sine x is 0 at those locations as well, it's my same solutions. So I'm looking for negative 2 pi, negative pi, and 0. There it is. All right, let's keep going to the next one. So this is the only one that we haven't hit, guys, but we will hit it next week when we start doing more trig properties of half angles and double angles. So sine 2x, this is the only one that you're going to have to do this for, 2 sine x cosine x, and we'll talk about where that comes from when we derive it from scratch. So let's write this out and then move that negative 3 cosine x to the left. So I'm going to write 2 sine x cosine x, and I'm going to move this negative 3 cosine x to the left, so plus 3 cosine x equals 0. When I do that, I can factor out a cosine x. So cosine x, parenthesis, 2 sine x plus 3 equals 0. Now, we do not have to worry about this one because 2 sine x plus 3 will never equal 0. You can consider this like maybe the sinusoidal axis or your shift, and then that too like an amplitude. So the biggest this will be, so I'm going to write 2 sine x plus 3. The biggest that will be is 5, 3 plus 2, see? And then the smallest this will be is 3 minus 2, so 1. Notice it's between 1 and 5. You'll never equal 0. So you don't have to worry about that one. But this one you do have to worry about. So, and that's not the only way to think about it, guys. You could have also like solved for sine x, right? You could have moved the 3 divided by 2. So sine x equals negative 3 over 2. And that will never happen. Sine x goes between negative 1 and 1. On the unit circle, sine x is between negative 1 and 1 as well. And also is a wave as well, right? But this one will happen. Cosine x equals 0. That one will happen. On the unit circle, cosine x is 0 at these locations. I'm looking between negative pi. Here's negative pi. And that happens to be pi as well. So I'm going to write pi. So let's go, let's see. Let's go counterclockwise. So negative pi over 2 is one of the answers. That's the one you hit first. And 0, then pi over 2. So negative pi over 2 and pi over 2. So there it is. Because this is where we start, guys. This is my domain. Start and finish. I'm only looking for answers between negative pi and pi. All right, let's keep going. Let's keep going. Hold on, guys. I got some text messages here. Okay. Here we go with this one. Sorry about that, guys. On this one, guys, it's always going to be the over 4s all the time. Take those 4s out. Look what you're looking for. You're looking for where sine squared equals cosine squared. That only happens, and you don't care about the magnitude because it's being squared. So we don't care about whether one's positive, one's negative. So here's a perfect example. Look at 3 pi over 4. At 3 pi over 4, the x value is negative square root of 2 over 2, and the y value is square root of 2 over 2. And look, so sine's the y, right? So this is being squared. So square root of 2 over 2 squared, and then cosine's the x. So negative square root of 2 over 2 squared. Now look what happens when I square the square root, so that becomes 2 over 4. 2 squared is 4. And when I negative times a negative is a positive, so 2 over 4. So look at that. So half equals half. So yeah, correct. So we don't care about the negative, guys. We just care that the magnitude is square root of 2 over 2. And that happens at all the ones where the denominator is 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that's always going to be like that. Even if they were to change the domain from negative 2 pi to 0, then obviously we're talking about the radians being negative. So it would be like a negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, negative 7 pi over 4. I guess going in order, if you're starting at negative 2 pi, you'd probably reverse the order, right? But they're all the 4s. I feel like that lawyer, like, call 4s. What is it, like Jim Farley or whatever his name is? All right. So yeah, so there it is, guys. All right. Come on in. I'm just making a video, so I'm like recording, you know. So it says 2 sine squared plus 9 sine. I'm not talking to myself, guys. There's someone that came into my room. Say hi. Hi. Yeah, see? All right, 2 sine squared plus 9 sine plus 4. So this is similar to when you were in algebra and you had 2x squared plus 9x plus 4 equals 0. There's so many ways to do this, guys. You can do guess and check. You can factor by grouping, AC method with combination factoring by grouping. So that's what I'm going to do. So when you were in algebra, let's do a quick overview. You probably did something like the AC method. So you multiplied 8 and C there. So that's 8x squared. And you said, what times what is 8x squared that adds up to a 9x? And maybe you said 8x times x. And maybe you did like some type of organizer, maybe like a box or something. So there it is. And then I'm going to replace a 9x. I'm going to replace a 9x with these two. So I'm going to go 2x squared plus 8x plus x plus 4 equals 0. And I'm going to group the first two and group the second two. And then I ask myself, what can I factor out of those first two? And I can factor out a 2x, and then I'm going to have x plus 4. So that's what I want. I want an x plus 4 again. So there it is. Notice you have an x plus 4, so I can't factor anything out of that other than a 1, right, if you want to say that. And that equals 0. So I want you to notice this product here and this product here. They both have an x plus 4 in common, and that's what I can factor out, guys. I can factor out an x plus 4. See? So when I factor out the x plus 4, what do I have left? I have this 2x and 1. So 2x plus 1 is what I have left over. Why does this work? Well, check it out. 2x times x, that's at 2x squared. 2x times 4, that's at 8x. 1 times x, that's at 1x. 1 times 4, that is at 4. See, so it works, guys. And then the only way you can get a 0 is if x is negative 4 or if x is negative half, right? And of course, you could always do the little math, right? 2x plus 1 equals 0, move the 1. 2x equals negative 1, divide by 2, x equals a negative half. All right, so there it is. So it's the same. So because, they're similar, not the same. Because they're similar, I can rewrite this one. And I guess let me go ahead and change the color now so you guys can see that I'm solving for this one now. I can rewrite this one as this expression, but instead of x, I'm going to write sine. So parenthesis 2 sine x plus 1. sine x plus 4 equals 0. And it's the same logic as before, guys. Sine x will never equal negative 4. So that's the only way you can get a 0 if sine x equals negative 4. But sine x is between negative 1 and 1, so we don't worry about this one. But we do worry about the 2 sine x plus 1, because that will be 0. Move the 1. 2 sine x equals negative 1. Divide by 2. Sine x equals negative half. On the unit circle, sine is negative half in quadrant 3 and quadrant 4. Hopefully you guys remember. Pause the video if you want to see if you guys can figure this out. X equals, this one over here in quadrant 3 is 7 pi over 6. And x equals the one in quadrant 4 is 11 pi over 6. So there it is. And there it is, guys. All right, so now that we have some experience, let's see if we can tackle this immediately. This one I would just do guess and check. There's only one way to get 2 cosine squared. 2 cosine x times cosine x. And there's only one way to get a 1 times 1. Make sure that you recognize that it's a negative one, so that means one of them was positive, one of them was negative. So here we go. 2 cosine x, close, open, cosine x, close, equals 0. And the only way to get a 1 is 1 times 1. All right, you want a positive. You want it to add up to a positive 1. So let's see. 2 cosine x times 1, that has to be the bigger number. So that's a positive 2. And then I'm going to subtract 1. And 2 minus 1 is 1 cosine. So there it is, guys. And I know I went pretty fast on that. So let me explain what I just did. I made sure that the middle term added up to a positive 1. See, look. I guess let's do it from scratch. 2 cosine x times cosine x. That's my 2 cosine squared. That's what I was talking about. That's the only way you can get that 2 cosine squared. 2 cosine x to a positive 1. So here it is. Plus 2 cosine x, negative 1 times cosine x, minus cosine x, negative 1 times positive 1, minus 1. And all that equals 0. See, this in here, you combine like terms. So 2 cosine squared x plus cosine x minus 1 equals 0. And that's what I have. So hopefully that made sense to you guys. Yay. All right, so let's solve this. So let's do this one first. Cosine x plus 1 equals 0. Well, that will happen. Move the 1 to the other side if cosine x is negative 1. That on the unit circle happens over here. My domain is 0 to 2 pi, so one answer is pi. Let's look at the other one. 2 cosine x minus 1 equals 0. Move the 1. 2 cosine x equals 1. Divide by 2. Cosine x equals a half on the unit circle. That happens twice. That happens up here and down there. That first radian is pi over 3. And the radian in quadrant 4 is 5 pi over 3. So let's look for those answers. All right, these are pretty simple, guys. You'll see that they're not that bad. What you want to do is get rid of that 4 by dividing by 4. Bam, bam. So now you have cosine squared x equals 3/4. And then what you're going to do is you're going to take the square root. Square root, square root. Now, your law of exponents, you're going to do square root of 3 plus minus over, well, I guess we'll bring the plus minus out in a little bit, over square root of 4. So you have cosine x equals, the square root of 4 is plus minus 2. So here it is. I'm just bringing it out. Square root of 3 over 2. So now, on the unit circle, we're looking for all of them of where I get square root of 3 over 2 or negative square root of 3 over 2. And that happens in all of these. See? And it's all the ones that have 6's in the bottom, right? Square root of 3 over 2, comma 1/2. This one over here is a negative square root of 3 over 2, comma 1/2. And we're looking for all the square root of 3's. This one's a square root of 3 over 2 again, comma negative 1/2. And this one over here is a negative square root of 3 over 2, comma negative 1/2. See? So all the ones will have a 6 in the bottom. Let's go to the next one, guys. This one's just the same as before. Move the cosine x to the left. So cosine squared x minus cosine x equals 0. And then we're going to factor out a cosine. If you just cancel one out immediately, you're not going to get one of your solutions. So here's my cosine x factored out. And you're going to have cosine x minus 1 equals 0. So where does this equal 0? Well, if cosine x is 0, that happens at pi over 2 and at 3 pi over 2. And where else does it happen? Well, if cosine x equals 1, right? Because if you have a 1 there, 1 minus 1 is 0. So that happens when x is 0 or 2 pi. So I'm talking about right here. 2 pi cannot be included. So there it is. Pi over 2, 3 pi over 2, and 0. All right, let's keep going. This is the same or similar to question 11. Similar to Q11. We'll do it. We'll do it. I was thinking about skipping it, but let's do it. Sine squared, and I'm going to move this to the left, so it's going to be plus sine x equals 0. And again, just factor out a sine x. So if you factor out a sine x, you'll have sine x plus 1, like so. And then remember, if you distribute this, you better get this expression there, and that's what I'm doing. So that's what's called factoring when you factor out your sine x there like that. All right, so now where does sine x equal 0? Well, sine x is 0 at 0, pi, and 2 pi. I haven't looked at my domain. Okay, there it is. So 2 pi is not included. So where is the y value 0? Here at these edges. So 0, pi, and 2 pi, but 2 pi is not included. And then this one here, well, the only way that will be 0, that expression, is if sine x is negative 1, and sine x is negative 1 down there at x equals 3 pi over 2. So there it is, guys, 0 pi and 3 pi over 2. So let's look for that. 0 pi and 3 pi over 2. All right, let's keep going. This one here, the best way to do it, in my opinion, I don't mess with cosecant. So just take the reciprocal of cosecant, which is sine, and keep the argument. So sine of that angle 2x equals, and remember that's like 2 over 1, so equals 1/2. I just took the reciprocal, guys. And then I'm doing inverse, so I'm going to have 2x equals arc sine of 1/2 plus 2 pi n. I think what I would do from there, I would just think about like, okay, 2x1 equals, the first time I have a half is, bam, at pi over 6. See? So where sine is a half, plus 2 pi n. And then I'm going to change my colors to a blue. 2x2 equals, the next time I have a half, bam, is a 5 pi over 6. So let me go back to red. And then to get x1 by itself, you just divide by 2. Put the 2 next to that 6 there. So from there, I get x1 equals pi over 12 plus pi n. Here's my general expression. I'm doing the same thing with x2 here. Divide by 2, divide by 2, divide by 2. x2 equals 5 pi over 12 plus pi n. All right. I'm looking for all the answers between 0 and 2 pi. I'm going to do a common denominator with my period here. That pi n, that pi is the period. 12 over 12. 12 over 12. So here are my solutions. I'm going to choose a neutral color like purple. X equals, my first answer is pi over 12. My second answer is 5 pi over 12. My third answer, 12 pi n over 12 plus pi over 12. 12 plus 1 is 13. 13 pi over 12 is smaller than 2 pi, right? Because 2 pi is 24 divided by 12. And then do the same thing with this one. 12 plus 5, 12, 13, 14, 15, 16, 17. 17 pi over 12. If you were to keep going, take that 13 pi over 12 and add 12 pi over 12. 13 plus 12, that's 25 pi over 25 pi over 12. Guys, this is larger than 2 pi because 24 pi over 12 is 2 pi. So all of a sudden you have 25 over 12. Well, that's larger. That's larger than 2 pi, see? So hopefully that made sense to you guys. And those are my 4 answers right there. So I'm going to look for that. And here it is. Let's see. Yep, those are the ones. Yay. Okay, we're almost done, guys. We're almost done. So here we got an expression, and we're just going to solve. So the first move is inverse sine. So I'm going to write x plus pi over 4 equals inverse sine of square root of 2 over 2 plus 2 pi n. That happens in quadrant 1 and quadrant 2. Bam, pi over 4 and 3 pi over 4. So there it is. Those are my 2. So here's my first bullet. I'm going to write x1 plus pi over 4 equals pi over 4 plus 2 pi n. These pi over 4s cancel out. Minus, minus. And there it is. x1 equals 0 plus 2 pi n. So there's my first expression. Let me get my second one, guys. I'm going to go to blue, and I'm going to write x2 plus pi over 4. See, I'm just writing this. And I'm writing where this happens again. That happens at 3 pi over 4. 3 pi over 4 plus 2 pi n. Subtract pi over 4, subtract pi over 4. You get x2 equals 2 pi over 4. Now that reduces plus 2 pi n. This reduces to pi over 2. So x2 equals pi over 2 plus 2 pi n. And there it is. I want all my answers between 0 and 2 pi, so you're not going to add 2 pi. My first answer is 0, and my second answer is pi over 2. So 0 and pi over 2. Oh, this person got it right. All right, let's keep going, guys. Question 15. We're almost done. We're doing the same thing. Arc cosine, arc cosine. So I'm going to write, because it's arc cosine, maybe it's easier to write it like this. X over 3 minus pi over 6 equals plus minus inverse cosine of a half, because that will take care of both your equations right there, plus 2 pi n. I'm going to move the pi over 6 right here. X over 3 equals pi over 6 plus minus arc cosine of 1/2 plus 2 pi n. And then I guess let's go ahead and take care of that. X over 3 equals pi over 6 plus minus, the first time that cosine is a half is bam, up there, pi over 3, because up here that's 1/2 comma square root of 3 over 2. And that's pi over 3 there, plus 2 pi n. I'm going to multiply everything by 3, guys. So I'm going to go times 3 times 3, because I want to get rid of the 3 in the bottom there. So x equals, when I multiply by 3, I get 3 pi over 6, which is pi over 2. Plus minus, and then the 3's cancel out, pi plus 6 pi n. All right, to get I'm going to do a common denominator, so I'm just going to turn that to 2 over 2, guys. So let's see what we got. It might be the same expression here. Yeah, it looks like it is. Look, pi plus 1 plus 2 is 3, so I'm going to have 3 pi over 2 plus 6 pi n. So it's not the same, but you'll see what I mean. X2 equals 1 minus 2. That's going to be negative pi over 2 plus 6 pi n. But you can't use this one. So sorry that I said same. You can't use this one because if I add 6 pi to negative pi over 2, you're outside this domain here. See? So you're not going to bother with that one. The only one you're going to bother with is this one. And there's my answer, 3 pi over 2. Okay, we got 2 more, guys. Here we go. The first move is divide by 2. So now I have sine of 5x minus, rewrite this as pi over 6. Pi over 6 equals negative square root of 2 over 2. And I'm going to do arc sine. So 5x minus pi over 6 equals arc sine of negative square root of 2 over 2 plus 2 pi n. And now what I'm going to do, I'm going to move this pi over 6 here to the right. And this one doesn't have a plus minus. So 5x equals pi over 6 plus arc sine of negative square root of 2 over 2 plus 2 pi n. Now I know that arc sine of square root of 2, negative square root of 2 over 2. Hey, Gonzalez. I'm recording, so I'm not talking to myself. I know that arc sine of negative square root of 2 over 2, that happens twice on the unit circle. So that happens down here and down here. So that's how I'm going to differentiate this. So let's do the 1 in quadrant 3 first. That's going to be the 5 pi over 4. So 5x equals pi over 6 plus 5 pi over 4 plus 2 pi n. And I'm going to do a common denominator, so let's just focus on this one. So 6 and 4. So I think the common denominator is going to have to be 12. So times 2 over 2 and times 3 over 3. And when you do that, you're going to get 5x equals 2 pi over 12 plus 15 pi over 12 plus 2 pi n. And so let's see, 5x equals 15 plus 2, that's 17. 17 pi over 12 plus 2 pi n. And then divide by 5. X equals 17 pi over 12 times 5 is 60 plus 2 pi n over 5. So there's one answer. So let me go to blue now. Remember that we said that right here, this situation, this one could also be in quadrant 4. So in quadrant 4, that's going to be 7 pi over 4. So you're pi over 4 away from 2 pi. So I'm going to rewrite it. I'm going to start it right here. 5x equals pi over 6 plus 7 pi over 4 plus 2 pi n. Again, I'm going to multiply. What am I going to do? Multiply this one by 2 over 2 and this one over here by 3 over 3. Common denominator. The common denominator being 12. So I'm going to have 5x equals 2 pi over 12 plus 7 times 3, 7, 14, 21. 21 pi over 12 plus 2 pi n. 21 plus 2, that's 23. So 5x equals 23 pi over 12 plus 2 pi n. Divide by 5, divide by 5, divide by 5. X equals 23 pi over 60 plus 2 pi n over 5. And my domain is between 0 and pi over 2. So that means it's just going to be the 17 pi over 60 and the 23 pi over 60. So there it is. And let's go to the next one, guys. We're almost done. We just got 3 left. I'm going to divide both sides by 2. So I'm going to go cosine 3x minus, this is the same thing as pi over 3, guys. Minus pi over 3 equals square root of 3 over 2. Oh, beautiful, beautiful. Inverse cosine. 3x minus pi over 3 equals, because it's cosine, maybe it's to your benefit to put a plus minus. Plus minus arc cosine square root of 3 over 2 plus 2 pi n. And then that will take care of both equations, right? Move the pi over 3 right there. 3x equals pi over 3 plus minus arc cosine square root of 3 over 2 plus 2 pi n. I kind of feel like here's a good spot where, and I know you can divide by 3 already right here, but I feel like this is a good spot to go ahead and insert your arc cosine of square root of 3 over 2. Come on in. Plus minus, so this happens at pi over 6 plus 2 pi n. And now I'm just going to divide everything by 3, divide by 3, divide by 3, divide by 3, divide by 3. Oh, I'm recording, so don't worry, I can edit this out. So I'm not talking to myself. What's up, Cash?
You need to pause it.
Oh, okay, I can pause it. I was just going to edit it out, but I'll pause it.
Let me
pause. All right, here we go. 3's cancel out. X equals pi over 9 plus minus pi over 18 plus 2 pi n over 3. I'm going to do common denominator here, guys. So I'm going to multiply this guy by 2 over 2. So x equals 2 pi over 18 plus minus pi over 18 plus 2 pi n over 3. So let's see what we get. If I add them, I'm going to call that x1. 2 pi plus pi is 3 pi. And 3 goes into 18 6 times. So I'm going to erase the 3 and the 18 and write pi over 6 plus 2 pi n over 3. If I subtract them, I'm going to write x2. 2 pi minus pi is 1 pi. So pi over 18 plus 2 pi n over 3. All right, so here are my answers. What's my domain here? Between 0 and pi over 2. So one answer is pi over 6, and the other is pi over 18. And if I add 2/3, well, 2/3 is bigger than half, so you can't. So that's it. So pi over 6 and pi over 18. Yes.
Thank you.
Mm-hmm. All right, here we go, guys. 2 questions left. Well, actually, 18, 19, and 20. My bad. I don't know how to count. 3 questions left. Factor out of 6. You're gonna have sine squared x plus 2 sine x plus 1 equals 0. This is very easy to calculate, guys, or to factor it out. That's the same thing as saying x squared plus 2x plus 1 equals 0. So that is the same thing as saying x plus 1 times x plus 1. So that's what I'm going to do. 6 parentheses sine x plus 1 sine x plus 1. So you could also say sine x plus 1 close it squared equals 0. It's all the same. When is this true? Whenever sine x is negative 1. Where am I looking at? Between negative pi and pi. So that happens on the unit circle down here. And if this is negative pi and I'm going towards pi, which is also there, it's only going to happen at negative pi over 2. So there it is, negative pi over 2. Bam. All right. Question 19, we got 2 left. Arc sine, pi x plus pi over 7 equals arc sine of 1 plus 2 pi n. So I think they're being nice because there's only one location where sine is 1. It's up here at pi over 2. So pi x plus pi over 7 equals pi over 2 plus 2 pi n. I'm going to move the pi over 7 right there. So pi x equals negative pi over 7 plus pi over 2 plus 2 pi n. And let's find the common denominator before we divide by pi. Times 2 over 2 times 7 over 7. So I'm going to get pi x equals negative 2 pi over 14 plus 7 pi over 14. All I did was find a common denominator, guys. 14 is a common denominator. Multiply the other one by 7. Multiply this one by 2. Plus 2 pi n. So then pi x equals negative 2 pi plus 7 pi. That's 5 pi over 14 plus 2 pi n. And then finally divide by pi, divide by pi, divide by pi. So x equals 5/14 plus 2n. So there it is, 5/14, guys. All right, last question. Whenever you get something like this, there's only one way to get a 3. There's only one way to get a 5. I would do guess and check because that's the easiest way. The only way to get a 3 is 3 sine, or the only way to get 3 sine squared is 3 sine times sine. Now, don't write this down because maybe it's wrong. I'm just going to mess them up. I'm going to try to mess it up on purpose. Let's see. I'm going to put the 5. Yeah, I'm going to put the 5 over here and the 1 here. And I think it's wrong on purpose. Check it out. 3 times 5 is 15, and 1 times sine is 1 sine. And the difference, or the sum of between 15 and 1 is 16, which is not negative 8. So that's how you know that the 5 and 1 go the other way around. See, now 3 times 1 is 3, and 5 times 1 is 5, and the sum of 5 and 3 is 8. Now notice it's a negative 8, so they both have to be negative. Negative times a negative is a positive, so there it is. You do not have to worry about the 3 sine x minus 5, because that will never equal 0, as you can see. But this one will work. Sine x will be 1, and where does that happen? At pi over 2. All right. That was it. That was the last one. So yeah, there it is, guys. Let me know if you have any questions, and we are done. Don't worry, I'm not talking to myself. I'm recording. All right, later, guys.